Hello students. So in this lecture we will learn about the alternating currents, which is a very important topic in the syllabus of class 12. Now this alternating current is important to learn because the power that is supplied in our houses and in establishments is in the form of alternating current. Basically alternating currents are produced by a generator. Any generator that works on the principle of EMF generation by change in magnetic flux. And as you know, when the magnetic flux changes, the EMF is produced. Now suppose if your EMF magnetic flux is in the form of a, a time varying function, or your magnetic flux is a function of time, which is described by this sort of equation, which is a time dependent periodic function, then the EMF that is obtained upon differentiating it is also a time varying function. And of course it is a periodic function. Sine and cosine are periodic functions with period of 2 pi. So basically what is the property of sine and cosine is that the functions repeat themselves at fixed intervals. They start from one value, reach the maximum value, go to 0, again go to the opposite side and again reach 0, or the mean position, or from where they had started. So basically this is an oscillatory behavior. In mathematics you must have studied the graphs of sines and cosines. So basically when sine and cosine appears in a physical phenomena, the basic process is an oscillatory behavior, a periodically changing behavior. This is what is happening. So this alternating current is something different from a direct current or a current supplied from a battery, in the sense that this current is not constant in time, but it is changing its polarity and its magnitude with time in a fixed manner. There is a particular frequency, means the number of times when it is changing its magnitude and polarity per unit time. So let us see how this alternating current is produced. So basically this video, this shows the setup where your alternating current is produced. You have a generator, and where the basic part is the magnet, and in this magnet what is happening that this coil is rotating in this magnetic field, and you can see that as the strength of the wind, because this coil is actually rotating due to the motion of the wind. In a thermal power generator uh, it is the thermal generation or heat that produces this sort of a behavior. And in a windmill, the moving air produces the rotation in the coil. And you see, as the wind strength is increasing, the strength or intensity of the bulb is increasing. And in the oscilloscope, you can see how the graph is appearing. The voltage produced by this rotating coil, which in turn is rotating due to the windmill or the speed of the wind, it is producing a sinusoidal or a oscillating nature voltage. And when the wind strength is 0, it becomes a straight line. So this is how the alternating current, not this is not the alternating current, but this is the alternating voltage that is produced in a powerhouse or in a power generation center, and what we get is an alternating voltage. This produces alternating current that we will see later in this slide. So this is a alternating current profile, and you have various parameters here. And these parameters, see, this is the amplitude which is changing. Amplitude means maximum value of the voltage, or which is the maximum displacement in case of a oscillation. So you change the amplitude, and what you see that the peak height is changing. So maximum voltage is changing when you change the amplitude. And here you can see the equation that represents the voltage, the oscillating voltage, and it is in the form of a sinusoidal equation. Now you can also see the other parameters how they change with the time. Suppose this is the amplitude you have fixed and now you are changing the frequency, and you can see the shape of the graph is changing. This is how the shape of the graph changes, or the frequency of AC voltage changes. In the next slide we can see here how this is occurring, how the variations, how they are different, DC and AC. DC means it is a constant voltage, it is not changing in time, and the AC, it is not a constant voltage, it is changing with time in terms of magnitude and direction. So basically what you are expecting, that when you connect a bulb with AC source, your bulb should flicker or it should go on and off periodically, but this does not happen. And why it does not happen, why it continues to glow even in AC, we will see this later in the course. Now here we have some very interesting situation which is described by some mathematical quantities. Now you see that you have a AC source and you have a resistance only connected in this circuit. These arrows are showing how the current and voltage are changing. The voltage is alternating voltage and the current produces alternating current. This is different from AC because the way the voltage changes and the way the current changes, it is very important. Now what you see here in this simulation, in this video, that the voltage and current, they change together. Means what I want to say is that the voltage and current, they follow each other. Means they change their values, they increase their, they reach their maximum values together, and they reach the zero value together, and they reach the negative values together. So this is a situation where we see that the voltage and current, they are following each other. You can see the moving arrows, this is in slow motion, and you can see how the things are changing. This is for inductance. So what is happening here, that the in case of inductance, it is